In this video, we solve problem 4.2.17 from Essentials of Statistics, 6th edition by Mario Triola. The problem statement says, use the data in the following table, which lists the drive-through order accuracy at popular fast food chains. We're asked to assume that orders are randomly selected from those included in the table. So this is the table that they give us. And the way we can interpret this is we've got 4 restaurants here. We're calling this restaurant A, restaurant B, restaurant C, and restaurant D. And then in this row, we have the number of accurate orders that came from each of those restaurants. So this 333 tells us that there were 333 accurate orders in our sample that came from restaurant A. And there were 280 accurate orders that came from restaurant B, and so on. And these down here list the orders that were not accurate in our sample. For example, this 39 tells us that there were 39 inaccurate orders from restaurant C. Now the question says, if one order is selected, find the probability of getting an order from restaurant C or D, or an order that is not accurate. As soon as I see that or, I know that I'm talking about or I'm looking for an answer that requires us to use the addition rule. So they say we want the probability of an order, or getting an order, from restaurant C or restaurant D, or getting an order that is not accurate. So I'm going to write that down now. I'm getting an order from C or getting an order from restaurant D, or getting an order that is not accurate. I'm just going to call it an inaccurate order. Well, we know from the addition rule that the probability of getting this happening or this happening or this happening is the probability of the first thing happening. I'm just going to write probability of C for probability of getting an order from restaurant C, plus the probability of getting an order from restaurant D, plus the probability of getting an inaccurate order. I'll just call it inaccurate. But we want to subtract any overlap. So we want to subtract the probability of getting an order from restaurant C that happens to be inaccurate. So if there was a probability, if there is an order that came from restaurant C that happened to be inaccurate, if I add this guy and this guy together, I accidentally counted that guy twice. So I don't want to count those twice. So to compensate for that, to make sure that we're not counting them twice, we're going to subtract the probability of selecting an order from C that also happens to be inaccurate. And the same thing could happen with an order from restaurant D. We could accidentally count orders that come from restaurant D that happen to be inaccurate twice. So we want to subtract the probability of choosing an order from restaurant D that happens to be inaccurate because we've already counted them twice here. Now we should also subtract the probability of getting an order that comes from restaurants C and D, but we're never going to have an order that comes from both restaurants at the same time. So that last probability is 0. That's just the addition rule. Let's think about it intuitively and then come up with the correct expression for that probability. And then let's show that that is equal to exactly what we get from the addition rule over here. Okay. Whenever I have a problem like this, involving either the addition rule or the multiplication rule, the first thing I like to do is total up my columns and my rows. So I'm going to compute the total in this row and in this row. And I'll do the same thing down here in this row. It's actually pretty easy. We're just adding. So if I want to find the total number of orders that were not accurate in our sample, I'll just add the total number of orders that were not accurate at restaurant A, and the ones at restaurant B, and the ones at restaurant C, and the ones at restaurant D. So I've got 333 plus 280 plus 247 plus 134. We add those up and we get 994. And then if we want the total number of inaccurate orders, we just add up the numbers in this row. There were 32 from restaurant A that were inaccurate. Then we had 59 from restaurant B, 39 from restaurant C, 15 from restaurant D. So we had 145 orders that were inaccurate. So if I want to know the total number of orders in my sample, I can just add the inaccurate orders, that 145 orders that we're talking about right here, to the number of accurate orders, that 994 that we're adding right there. So we've got 994 plus 145, and that is 1139. So there are 1,139 orders in our entire sample. Oops. Total, there we go, number of orders. Okay. Now, if I add up all of the orders from restaurant A and B and C and D here, and then I add those up, I should also get the same total number of orders. So this is a great way to just check your arithmetic, or your typing if you're just typing this into your calculator. So we're going to do 333 plus 32. That gives me 365. That tells me that there were 365 orders in our sample that came from restaurant A. Then I've got 280 orders from restaurant B that were accurate and 59 that weren't. So there are 339 orders from restaurant B. Then we've got 247 accurate orders from restaurant C and 37 inaccurate orders from restaurant C. We add those together and we get 286. And then you've got the 134 that were accurate from restaurant D and 15 that were inaccurate from restaurant D, and we get 149. Now, again, if I add those together, I better get that 1,139, the total number of orders in our sample. It's always a good idea to just check, because we understand the concepts. Sometimes we type things in wrong, though. So I still get 1,139. Okay, very good. That's a good sign. Now I can answer this question. This says, if one order is randomly selected from these 1,139 orders, the question says, find the probability of getting an order from restaurant C, or getting an order from restaurant D, or getting an order that is inaccurate. Well, the orders that are inaccurate are represented by this row right here. So the probability of getting an inaccurate order is 145 out of that 1139, or 1,139. So that's the probability of getting an order that's not accurate. What about the probability of getting an order from restaurant C? Well, with restaurant C, I'm interested in the numbers in this column. There were 286 orders from restaurant C out of that 1,139 orders. And then if I'm interested in the probability of getting an order from restaurant D, I would look at this column. There were 149 orders out of that 1,139 that came from restaurant D. So if I want the probability of getting an order from restaurant C or restaurant D, or getting an order that's inaccurate, basically I need to add up all the values in this row. So that's going to give me all of the inaccurate orders, plus all the values in this column and all the values in this column, and then divide by this. But we have to be careful. When we look at the orders that are inaccurate that are here, and the orders from restaurant C here, and the orders from restaurant D there, if we were to just take these numbers at the ends, we would accidentally be counting these guys twice. I'd be counting that 39 twice, because I'd be counting those 39 inaccurate orders from restaurant C when I come up with the number of orders from restaurant C and the number of orders that are inaccurate. And I'd be counting these guys twice because, well, I've got inaccurate orders from restaurant D here. And they're also, from restaurant D. So I'd be counting them in this number and this number, and also in this number. So these guys have been counted twice. So we're gonna have to subtract them. So if I want to use the addition rule to find the probability of getting an order from restaurant C or D, or a restaurant or an order that is not accurate, I need to take the probability of choosing an order from restaurant C, which we can write down right now because of our work up here. The probability of choosing an order from restaurant C is 286 divided by 1139. And then I'll add the probability of choosing an order from restaurant D. There were 149 of those. So 149 out of that 1,139 orders came from restaurant D. And then the probability of choosing an inaccurate order, well, there were 145 inaccurate orders out of that 1139. So that's this right here. But if I add those together, I accidentally counted these guys twice. I counted these 39 with the inaccurate orders, and I counted them with the orders from restaurant C. I also counted these 15 orders that were inaccurate with the inaccurate orders and with restaurant D. So I need to subtract those. So I need to subtract the probability that something came from restaurant C, or the order came from restaurant C and it was inaccurate. So that's subtracting 39 out of 1139. And then we're subtracting the probability that the order came from restaurant D and is inaccurate. So that's 15 out of 1139. I hope that makes sense to you. The idea is we just want to count everybody once. We want to count all of the orders once. So intuitively, if I wanted to find the probability of getting an order from restaurant C or D, or an order that's not accurate, all I would do is find all of the inaccurate orders, so there are these, and then find all of the orders from restaurant C, these, and all of the orders from restaurant D, these, and I would just add those together and divide by the 1139. So let's do that. So I've got probability of choosing an order from restaurant C or D, or an inaccurate order, is this. I'm just looking at the numbers in this row and I'm writing them down and adding them together. So I get 32 plus 59 plus 39 plus 15. And I also want orders from restaurant C. So I want that 247 there. And then everything in this column, but I've already counted that one. So I'm gonna get, just add that 134 there. So I add all of those together and I divide by 1,139. And that's going to give me this. So I get 526 divided by 1,139. So that's the probability of choosing an order from restaurant C or D, or an order that is inaccurate. That's the intuitive approach. Now, I claim that the intuitive approach gives us exactly the same result that we would get using the addition rule. So we take the probability of choosing an order from restaurant C, which is that 286 out of that 1139. And then we add the probability of choosing an order from restaurant D, which is 149 out of 1139. And then we add the probability of selecting an inaccurate order, which is 145 over 1139. But then we say, okay, in doing that, when we take this over this, plus this over this, plus this over this, there were some entries that we counted twice. It was this guy and this guy. So we have to subtract the probability of choosing an order from restaurant C that happens to be inaccurate. So we're going to subtract that 39 over this because we accidentally added it twice. We accounted for that 39 both here and here. And then we want to subtract the probability of choosing an order from restaurant D that's inaccurate because we counted those 15 twice. We counted those 15 here and here. So we're subtracting those. And then lastly, we would also want to subtract the probability of choosing an order from restaurants C and D, but you can't. You can't choose an order from restaurants C and D. Those two are disjoint events, so the probability of that is 0. So let's add all of these up and then subtract this and show we get exactly the same answer that we would get with that intuitive approach. So we're expecting 526 over 1,139. Let's see if we get the same thing. So I've got 286 plus 149 plus 145. That's all in the numerator over 1139. And then we're subtracting 39 here because we counted those 39 twice. And we're subtracting 15 there. And we get 526. 526 out of 1,139 is what we get. So we can just apply that addition rule, but it's not a good idea to just apply a formula blindly. Never a good idea to do that at all. Instead, we want to make sure we understand that formula and where it comes from. Anytime we're looking at subtracting these pieces, we're subtracting these pieces because when we add these probabilities together, there are some times in adding these probabilities together that we're counting orders in this case. We're counting some events twice, and we don't want to count them twice. We only want to count them once. So that's why we have to subtract that 39 out of 1139, and we have to subtract that 15 out of 1139.